Assalamu alaikum wa rahmatullahi wa barakatuhu. Friends, welcome back to my channel. In this video, I will make a review after a 3-month practical experience on this multimeter. I used it for 3 months. After 3 months, what is my opinion? I will share my opinion. It is not any kind of paid promotion, or I am not endorsing any equipment or any site. I am just sharing my personal practical opinion on this device. According to my opinion, it is useful. So let's start. In this session, we will test its all parameters. We will compare it with my second multimeter, the Fluke, which is I also use for a long time. And we will compare the both multimeters and we will check what is here, what is there. And if you have any suggestion, if you have any comment, if you have any question, kindly write in the comment box. I will welcome. Let's start. I purchased this Aneng Q1 multimeter on 8 April 2021 and today it is 10th July 2021. After 3 months of its use, and I will share how did I find this product. When we purchased this product, a very nice handy multimeter. It is 146 by 76 by 34 mm. And it have a nice grip. Its outer cover is very nice and safe. Here we have a sticker for warning for current probes. Do not measure voltage at these two ports, these test points. This multimeter is not supplied with batteries, so you have to install batteries. To install batteries, remove this cover. Here is a screw. 2 AA size batteries. Take care for the polarity. Negative side here and negative side here. So this multimeter is now ready to use. Operator manual. Then we have test lead with protective cap. To prevent the jacks from corrosion and humidity and everything. Here we have positive lead, red lead at temperature, volt, ohm, frequency, capacitor, diode and continuity, and this one is common for voltage and current. Here is milliampere socket and microampere socket, and here we have ampere socket. So we have to swap this lead to here when we want to test current. In normal measurements we have to install this red wire here. So it have a protective cap on the test probes, so it is safe for measurement when we make a very close measurements, and it have very sharp ended test probes, so it is easy to poke on the PCB when we are working on special PCBs when it have a coating. So you can just press it and it will make a good contact. And when we want to measure in some sockets or some cables like this, so you can remove these caps and you can test it. Then we have this thermocouple for temperature measurement for degree centigrade, Celsius and Fahrenheit scale. So this thermocouple is very nice and we can use it to test any cylindrical hole, any point where we want to test some temperature, so we can touch it inside any cylindrical hole. Then it have very nice test accessory for testing, for test purpose. It is a universal test lead. both ends of the cables test leads are free. You can modify, you can adjust it for your requirement. A common test probe, you can use it as a common test lead. This is at operator end, and this for the multimeter. We have a complete set for test aids. We have two pairs, nice looking quality banana test jacks to connect this cable with multimeter. So we can insert in the test socket, and we can use these test leads for test purpose. Then we can also use a spade connector. Spade test terminals or U-shape insert, it is called spade connector, or it is also called U-shape insert. So we can connect it, we can connect to any chassis, any screw. We can use it as per our requirement. We can use also, if we want to make a ground with this spade connector, insert to any screw, and we can use one lead to test socket. A common test probes. Yes, it is here. Just tight it. Then we have this alligator set. Use it as a power application. We can modify this cable as per our requirement. It's user manual. When we study it, safety informations, safety points are discussed here. Different indications here. Every indication is described very nicely. Then we have different controls and their definition, very nicely explained. How to make measurements using these test sockets, how to measure AC voltage. So we can understand every function very nicely for measuring AC voltage, DC voltage, measuring resistance, frequency, diode and continuity, frequency and duty cycle, capacitance check, temperature and non-contact voltage. Here it is maintenance and how to replace batteries, fuses, ranges and specifications. Just only one aspect that is missing in this technical manual, that there is no description about calibration. Either it is self-calibrated or it needs calibration. When we power on, press this switch for 2 seconds. It have a nice display. It is reverse LCD. Here it says DC auto ranging. That means this time it is working in auto range mode, DC measurement. Millivolt, it is 9999 count multimeter. It have analog bar graph. Now it is in DC mode. We will compare this multimeter with Fluke. It is not a standard, but we can compare. I applied 24 millivolt signal. Here we have 24. Here is 23.9. I applied 250 millivolts. 250, 249.4. So it is acceptable. I applied 500 millivolts. This multimeter is reading 499 millivolts. It is reading 499 millivolts. That's perfect. So both multimeters are giving the same reading. I applied 1 volt. So both multimeters are reading 1 volt. I applied 5.5 volts. So 5.5, 5.5, 2 millivolts difference. That's not a difference. I applied 9.90 volt. It is giving 9.90. It is 9.90, 9.89. So it is perfect. I applied 20 volts. It is reading 19.99 and it is reading 20 volts. It has bar graph here. Same bar graph here, analog bar graph and analog bar graph. I applied 30 volts. This multimeter is measuring 29.98. It is measuring 29.99 or 30. I applied 40 volts. This multimeter is measuring 39.99. It is measuring 40 volts. So for DC measurement, I am confident that it is measuring perfect. When we use any test equipment, if the test equipment is giving a good result, then we can troubleshoot any circuit very nicely. Let's check safety. For example, I am measuring in DC voltage range. Here, DC voltage range. If I swap this multimeter, it have a selector knob. I move to AC voltage. This time, it does not display anything. If I move back to DC voltage, it is measuring the same reading. For example, it is DC voltage range, and if I switch this multimeter to millivolt range, it is off. Now I made this circuit. I powered on. For DC voltage, from here to here it is 12 volts. From this voltage divider network, I will make this lead as a common. I have 12 volt here. From this point to this point I have 4.76 voltage. Up to this point 9.55 volt, and this point 12 volt. This resistor 4.78 volts, 2.4 volts. Now when I take measurement at this point and I will press this relative function for 2 seconds, it shows the triangle. Now it is measuring 0 volt at this point. Here it will measure the voltage just only for this resistor, and now we can compare. This reading is 00 now. Now we can check difference from that reference value. It is 0.19 millivolt more. If we check from this point to this point, it will exclude this reading, and we will see just only this voltage reading. And if we check, if we set relative voltage here, now we can check this resistor is dropping 20 millivolt more than this resistor, and we can also compare this resistor. It is dropping less voltage, we can say. So this resistor is minus 2.35 volts less than this. So this resistor is dropping less voltage with respect to this. So it is relative function. Press 2 seconds and it will return back to the normal reading, and we can check now. It is 9.5 volts, 4.7 volts. If we want to take a reference from this resistor, 2 second, press relative function. Now this resistor is 0. It is dropping voltage. It have 2.4 volt, but now it is 0. With reference to this, how much relative voltage are more? It is dropping 2.37 volt more than this. Here are 2.37 volt more than this resistor, and here 2.35 volt more than this resistor. So in this way we can compare the circuit using this function. We don't have relative function in this multimeter. We can hold any reading for any time, just only press once, it is hold. If you will press for 2 seconds, that will shift it in relative mode. Just touching it, it will freeze reading. Now we can check AC voltage. We can use this stand for a good reading, for a direct IVN. This time there is a reflection in the glass for camera, so it is best to use this multimeter in this direction so that it will a good display. Now it is DC range. I have to press this button again to switch in AC range. For measuring AC voltage, it displays auto range AC. Here we have analog bar graph, and here we have digital display, and we have secondary reading here. Here we will find voltage, and here we will find frequency. That is wonderful. It is giving 230.6 volt, 49.97 hertz. If we compare the second multimeter, 230.7, and then we have to go to the frequency mode. It is 50.0 hertz. So that's good. Yes, it is giving 50 hertz, 50.01 hertz. So the frequency is same. And 230.7 volt, 230.5 volt. So both readings are nice. Here we have an additional thing, that we have secondary measurement here. We have bar graph here, and we have also an analog bar graph here, and here it displays true RMS. This multimeter is also true RMS, so it displays that these voltage are true RMS. That's good. 115 volt, 114.6, 114.9. So we can check here the frequency, and here we have another extra option that is not available here. If we press this button, that is for frequency and duty cycle. We cannot check duty cycle with this multimeter, so we can check the duty cycle. Here it is 114.5 volt, 49.96 hertz, and if I press this button, that is hertz and frequency. So now hertz will shift in the main reading, and we will see 50% duty cycle. That is wonderful. Here we cannot check the duty cycle. So this multimeter have an additional option for checking the duty cycle. It is auto ranging millivolt, volt, and we can also select our desired range from here, this range button. Now it is manual ranging. It will shift the digit. Then this multimeter have a very useful option for NCV, non-contact voltage. That is to locate any electrical field, that there is electrical voltage available in some cable, in hidden voltage. To find hidden voltage, we can use this feature. Power on. Press this button. We will shift in AC mode. Then EF. So this mode is for hidden voltage. Here is a sensor for this hidden voltage. It will show that here are some voltage. For example, we have some hidden voltage here. We can locate where is the strong magnetic field. If we locate here, no electrical field. We move it. It will display single bar that it have some distance, and the beeps are with long interval. When we are getting closer to this cable, it is displaying 2 bars. Now we located the maximum electrical field, that at this point it is the most strong electrical field. So here we have electrical power here. So it is very useful option. It is not available in this multimeter as well. To test millivolt in DC power on, press this button, and now we are in millivolt range in DC. If I apply more voltage, it says over range, OL, overload, that the input is applied more than the multimeter range. When I will decrease, I applied 5 millivolts, 5.0, 4.99. That's very nice. So it is reading with microvolt accuracy. So both multimeters are giving good reading. So here I applied 62.5 millivolts. It is reading 62.5, and this multimeter is reading 62.5 millivolt. And if we move to DC range, it is reading 62.5, and here 63 millivolt. So both multimeters are giving good reading. I applied 100 millivolt signal. This multimeter is measuring 100 millivolt, but it displays overload. So it can measure 99.9 millivolts. So here I am taking 99.8, 99.8. When I apply 100 millivolts, so it will say overload because it have maximum range 99.9 millivolt. That's very nice. After that we can shift to the DC voltage range. In DC millivolt we tested it from 0 to 99.9 millivolts DC, and at the same point we can test AC millivolt. Unluckily this time I don't have AC millivolt source, so we can skip this test or we can compromise. Then in AC voltage, this multimeter have frequency response from 40 Hz to 1 kHz. The same is here, from 40 to 1 kHz. What is frequency response? Hz. I have 10.5 volt, and if you want to check the duty cycle of this frequency, just only press this frequency button. So 40 Hz, 49.9%. This is duty cycle. Press again this button and we will go back to the same menu. It is 10.55 volts. Now if I press 500 Hz, it is giving 500 Hz 10.23 volts. If I press 99 Hz, the voltage level dropped 9.88, and if I put frequency 2 kHz, the voltage started dropping. In AC voltage frequency response ACV, 40 Hz to 1 kHz. We have to check the operator manual. We can measure up to 100 kHz frequency here in the same AC voltage range. I will set 50 kHz. It is giving 50 kHz. Check frequency here, 50 kHz. But if we check voltage, the voltage dropped up to 68 millivolts. If I set 99 kHz, the voltage dropped up to 16.5. We can check frequency here up to 100 kHz. 100 kHz. So that is 100 kHz frequency here. If we want to test the frequency more than this, then we have to shift to AC millivolt. Now we will go to the frequency menu. It is giving 100 kHz with 50% duty cycle. Now I will check 200 kHz, 300 kHz, nice, 500 kHz, and if we check duty cycle, shift 600 kHz, 900 kilohertz. So it is giving 900 kilohertz. 1 megahertz. It is giving 1 megahertz. 2 megahertz. So it is giving 2 megahertz, but this time display started flickering. If I put 400 kilohertz, it's good. 1500 kilohertz. It is giving 1.5 megahertz. 2 megahertz. It is giving 2 megahertz, but this time the digits started flickering. 1 megahertz. 5 kilohertz. In frequency measure, only 100 kilohertz under AC voltage setting. When the frequency is to be measured is between 100 kilohertz to 500 megahertz and enter in AC mode, AC voltage mode, okay, AC millivolt mode, touch the probe to the desired points. So we connected the probe and it is claiming 500 megahertz, but at 2 megahertz the multimeter is flickering. But 2 megahertz, that's wonderful. In multimeters, if we take 1 megahertz, that's enough according to my experience. As it is mentioned in 500 megahertz, so I think there is a mistake. As we practically see, either maybe it is 500 kilohertz. Yes, it is 500 kilohertz, that's good. I think from 100 kilohertz to 500 kilohertz, it is not in megahertz, because megahertz frequency for frequency counters. So I think this is 100 kilohertz to 500 kilohertz. So it is very useful. 900 kilohertz. 900 kilohertz, it's enough. Now the next function here in this button, that is temperature. Connect the thermocouple, the temperature probe, power on. Initially this multimeter will turn on DC voltage range. So we have to go to this button. DC millivolt, AC millivolt, then the temperature probe. This time I am taking 22 degrees centigrade because this time my lab temperature is 22 degree. So it is showing the same 22 degree. That's wonderful. So we can test the temperature. So it's good. It is measuring the temperature. We are getting two readings in degree centigrade, degree Celsius and degree Fahrenheit. The next setting, that is capacitor, diode continuity and up to 100 mega ohm resistor. We will use these test leads. Power on. We are in DC range. Press this button. Now it is in kilo ohm range. To test resistors, I selected some fixed resistors because resistors with tolerance will not give a good reading. So it is VR39, 0.39 ohm resistor. First of all, check the error of the ohm meter. Here we have 0.11 or 0.1, and here we have 0.2 error, 0.1, 0.2 error of the test leads and the multimeter. First of all, we will check this reading. 0.6 minus 0.2, that is around 0.39 ohms. 0.5 minus 0.11, it is 0.39. Then I have 1R00, the second resistor, that is 1R00, 1.00 ohms. 1.00 minus 0.11 error, it is reading 1 ohm resistor. We have another option, just only make the both leads to 0. Wait until this multimeter will, so it is stable at 0.15. Press relative button. So now this multimeter will exclude this error from its measurement. It is measuring exact 1 ohm, 1R00. That's nice. And if we check with this multimeter, it is 1.2 ohm. But when we apply a relative function, it will give the perfect measurement. 1.2 ohm, 1 ohm. Because we are using a relative function now. We are excluding the error. So we can take the perfect V680. 680, that means 68 ohms. It is giving 66.39. 66.4. 66.39, it is exact reading, because here it is adding error. The next resistor is 1000, that is 100 ohm resistor. So it is 100.4, 100 ohm resistor. That's nice. Now we have resistor 111.111. 111, it is measuring 111.2. This time I made exit for relative function, so it is giving 111. So for fixed resistors, it is 111.2, the same readings from both. Now I will check 4990, that is 499 ohms resistor. It is giving 499.9. Wonderful. It's giving 499. Now I will check 7.75 ohms. So I am taking 7.77, 7.78 instead of 7.75. Now check this multimeter. It is giving 7.9. So here we have accurate measurement. Then I have 40R2, 40.2 ohm resistor. So this 40.2 ohm resistor, it is measuring 40 ohms, 40.07. So here is 40.2 minus 0.2 error, 40 ohms. 40 ohms here and the same 40 ohms here. That's good. So now we will check 10 kilo ohm resistor, 10.01. It is 1002 code, 10 kilo ohms. It is measuring 10 kilo ohms. So the resistor range is good. The next, it is continuity. To test continuity, power on, move to continuity, diode and continuity by pressing this button. Now we are in continuity mode. We can test the buzzer. We can test diodes. At the same point, it is giving 0.6 volt. Open, open, 0.7 volts. For example, we have to test this wire. We can check continuity, so it will give continuity. We can test LEDs. Now this LED is giving 0.188. We will swap the reads. So this LED in both direction, same reading, so this LED is bad. We can test this LED. So this LED is on and we are seeing the dropped voltage of the junction. That's good. Green LED, yellow LED and we are seeing the drop voltage 1.854, 1.86, 1.8283. Now we can check capacitor. To check capacitor, press this button another time. So it is now in NF, nanofarad mode. Or if you are turning on first time, power on, press this button 1, 2, 3. 3 times this button, and now we are in nanofarad mode. First of all, discharge the capacitor. We discharge the capacitor and it is giving 91.15 microfarad. 91.91 microfarad. And this capacitor is 100 microfarad. We will discharge it and now we will test it here. It is given 94. Now we can check the other capacitor. It is 11.0 and its value is 10 microfarad. Discharge both leads in capacitor mode. It is giving 11.4. So both multimeters are giving good reading that the capacitor is good. Now we can check this capacitor. 1 nanofarad, 1.08. One nanofarad. If I check this capacitor, 3300 microfarad with this one, it is giving 2.9 millifarad, 2.944 millifarad. We can say 2945 microfarad. We have to discharge it. So both multimeters are giving approximately the good reading, that is 2981. That means this capacitor have 2981 microfarad. It is giving 2947. That's not a big deal, so it is working good. If I check this 22 microfarad, black lead to common, it's giving 26 microfarad. Because this is best quality capacitor, 26. The same is here, 26.4. If I check 5600 microfarad, I am taking 6128 microfarad. It's giving 6034. That's good, because these capacitors always measure extra than the rated value. It is for 5600 microfarad, but it will give 6000 microfarad, because in this type of capacitors, for a good brand, because it is made in USA, if you will measure this one, a local quality, it was measuring 3000 microfarad instead of 3300, but it is measuring 6000 instead of 5600. Then we have a current measurement. For current measurement, normally we don't have any button here, but when we will connect this lead, it will swap automatically in current measurement, and we can just only press this button for swapping in DC milliampere and AC milliampere. Just we remove this lead, it will switch in the ohms and voltage. When we insert this lead, this multimeter will automatically shift it in ampere mode. So let's check the current. We will connect both multimeters in series so that the both readings will be evaluated. For current, for DC ampere, I will connect the negative terminal to the negative side, and positive out of this multimeter, I will insert it to the negative terminal of this multimeter, and the positive of the battery terminal we will connect to 150 ohms resistor, one end to the battery terminal, and here we are connecting. So I applied voltage here to one multimeter, and common of this multimeter is going here to positive of this multimeter, and this lead is connected to the ground. Now I will apply some voltage and we will check the current. So both multimeters are measuring 2 milliampere DC. I am taking 12 milliampere, 12 milliampere. Both readings are equal. Now it is 100 milliampere to 150 ohm resistor. We are taking the same current reading, 100 milliampere, 100 milliampere. Now 234, 234. That's good. Now I will change the resistor. Now I will change with 47 ohms. 500 milliampere, 500 milliampere. $730, $731 milliampere, 842, 844. Now I will change the resistor. I will use 6.6 ohms to take more current. 6.8 ohms resistor, and now we will take more current. At 1 ampere both multimeters are giving the same reading. Two ampere, I applied 5 ampere and this resistor is damaged. Now we are taking 3 ampere, and if I will exceed from this rating, in that case might be this resistor will not handle the power, because we will exceed from its watt rating. Now I will increase the watt rating and this resistor will destroy it. So let's check it. Never do this. It started discoloring. At this 5 ampere, it is damaged. Why? Because I exceeded the power limits. Never try this. Up to 5 ampere our multimeter is giving good reading, milliampere reading. In the same way, we have to connect a load resistor and we can take a current. Now, as a final opinion, this multimeter, its price is above $300, and this multimeter is just I purchased in $30. If we compare this multimeter with this one, this is Fluke. If we compare price, it have 10 times more price. So if you are looking for a good multimeter, good test device with useful features, I will recommend that this multimeter is useful for practical work. Now if you want to troubleshoot a switch mode power supply, we can check DC voltage. It is giving 162 volt. Why? Because I am working in 115 volts in input line. Now in any power supply we need either this IC is switching or not. It is our first requirement that we are using multimeter. So just only move to AC voltage and connect across the transformer primary winding. So it is working 349 kilohertz. To take a good measurement, because this multimeter have frequency response 1 kilohertz, it can measure frequency up to 100 kilohertz in AC voltage range. To measure more frequency, move to millivolt AC and press the hertz button here. Now we are taking the exact reading, that is 380 kilohertz, 47% duty cycle, and we can check the frequency in the output side. It is 379 kilohertz. That's good. So for working on power supplies and VFDs are like that, I think this multimeter is good. I am not promoting any site, any equipment, but if you want to select this multimeter, I will give the link in the description. That is banggood.com. It is Aneng Q1, 9999 count. Very nice design, and that's good. I hope so this video is informative. If it is informative, give a thumb up. If you have any question, please let me know in the comment box. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.